All right, so for this problem, the first thing we're going to do is we're going to examine to make sure, are the x's, the y's, and the z's lined up? They are. So we can proceed forward. And then we're going to look at the x's, the y's, and z's and decide, is there one variable that appears easiest to eliminate? There is no wrong answer with this, but it does make it easier if you choose one that is easily eliminated. Like when I look here, do you see how the x's could eliminate right away? So I'm going to choose to eliminate the x's. So I'm going to write the first and the last equation to the right. I use the first and I use the last. I'm going to maybe make a little check mark here so I remember. I've used the first and the last. And now it makes it easy. I don't need to multiply by anything for any variable to be eliminated. When I add straight down and I simplify the x's, I end up with 0x. 2y minus 1z equals 5. And then I'm going to take a highlighter and I refer to this as a boxed equation. The next thing I'm going to do is I'm going to take, please listen, I'm going to go back and find out which equation have I not used up above. It happens to be the middle equation. I'm going to write it down. And now I have a choice. With the middle equation, would it be easier to cancel out the same variable x if I combine the middle equation with the top or the middle equation with the bottom? There's no wrong answer once again, but there is an easier way. I'm going to choose to write down the last equation. And I did that because I can see they are different signs. So I need to continue canceling the same variable x. So if these two have to cancel, and it doesn't appear like they're going to cancel without me doing something. So I'm going to go, what number or what value does 3 and 2 both divide into? And the smallest number would be 6. So if I multiply the entire first equation by 2 and the entire second equation by 3, I would end up with 6x plus 4y plus 8z equals 32. Negative 6x plus 9y plus 3z equals 18. While I provide you time to continue writing, I do want to add that oftentimes students forget when they distribute this value, such as 2, to distribute all the way back to the constant at the very end. So take it times 3, 2, 4, and 16. Okay, now it's time to combine these two. So when I combine down and simplify, I end up with 0x. 13y plus 11z equals 50. And box it in. Now we're going to take the two equations that were boxed in, and we're going to write one on top of the other. Notice that we only have two variables because in both situations we've eliminated the x for both. So I have two variables left. And right now when I look, the y's don't cancel if I combine, and the z's don't cancel. But which variable appears easier to cancel at this point? The z. So I put parentheses around the top, and if I multiply everything by 11 in the first equation, I end up with 22y subtract 11z equals 55. Okay, combine. 22y plus 13y is 35y combined to give you 0z equals 105. I'm going to continue to solve for the variable y. and y equals 3. We're 85% done with this problem, and we've done all the hard work. So what's the next step? It's almost like you're working yourself backwards. So the next step is to look at the two boxed equations. There is no wrong answer again. Which equation, the first one or the second one, appears easier to work with? The first one. So I'm going to write down the first boxed equation, and wherever I see a y, I substitute in the value 3. Continue to solve right now for z. Okay, here we go. And again, we're going to just continue to work ourselves backwards to the very beginning. So I'm going to take the values of y equals 3 and z equals 1 and look back at the original 3 equations. There is no wrong answer. Which one appears the easiest to work with for you? I'm going to say the first one, but there's no wrong answer. So I'm going to write down the first equation. And wherever I see a y, I substitute in a 3, and a z, I replace it with 1. Please solve for the variable x. So I broke the code here. X is 2, y is 3, and z is 1. What does that mean? That means if I take those 3 values and I substitute them in for x, y, and z, the first equation would equal -1, the second would be 16, and the third would be 6. It also means that if I graph these 3 equations, they would intersect at one point, the point 2, 3, 1, this ordered triplet.